The most powerful solar flare in over 2 decades could hit Earth sometime in the next 18 months. And the strange part? The sun's peak activity already passed. Scientists now predict the real danger is still ahead of us. There's a pattern hidden in the data that most people don't know about. The largest flares don't happen during solar maximum, they happen after. And if the prediction holds, one piece of equipment scattered across every continent will determine whether we lose power for hours or for months. Last weekend, the sun reminded us it's not finished. A G3 geomagnetic storm slammed into Earth's magnetic field, pushing Aurora as far south as Montana and Wisconsin. Solar wind hit speeds of 567 kilometers per second. The interplanetary magnetic field swung sharply southward, opening Earth's magnetic shield like a door. That was just one coronal mass ejection. But something bigger is brewing. A recent study analyzed 50 years of solar data and found a troubling pattern. The most extreme flares, the ones above X14 on the scale, don't cluster around solar maximum. They tend to arrive during the declining phase of the cycle, sometimes years after the peak. Solar cycle 23 peaked in 2001. Its most devastating flares came in 2003, 2005, and 2006. Solar cycle 24 peaked in 2014. Its 2 largest flares exploded in September 2017, more than 3 years later. Now we're in cycle 25, and the peak already passed in October 2024. So where does that leave us? The study projects that the strongest flare of this entire cycle will occur around May 2028, but the window for extreme flares, those monster X14 plus events, opens much sooner, between May 2026 and December 2027. That window starts in about 6 weeks. Here's what makes this cycle different. Every prediction was wrong. NASA and NOAA originally forecast a weak cycle with a sunspot number around 115. Instead, we hit 200, nearly double. The sun has been angrier than anyone expected. In early February 2026, sunspot region AR4366 unleashed 4 X-class flares in 24 hours, including an X8.1, one of the strongest in years. Radio blackouts swept across entire continents, and that was still below the extreme threshold. The scale matters here. An X1 flare is 10 times more powerful than an M1. An X10 is 10 times more powerful than an X1. The Carrington event of 1859, the one that set telegraph offices on fire, is estimated at somewhere between X40 and X50. The Halloween storms of 2003 included an X45. That one temporarily blinded satellites and caused a blackout across Sweden. Now remember that piece of equipment mentioned earlier, high voltage transformers. These are the massive units that step power down from transmission lines to local grids. They weigh hundreds of tons, they take years to manufacture, and during an extreme geomagnetic storm, they can be destroyed by induced currents flowing through the ground. The United States has roughly 2,000 of these transformers. Almost none of them have spares sitting in warehouses. A 2013 study estimated that a Carrington-class event could knock out 365 of them simultaneously. Replacing them all would take 4 to 10 years, not because we lack the technology, because we lack the manufacturing capacity. This is the holy shit moment most people miss. A sufficiently extreme solar flare isn't just about losing cell service for a few hours or seeing pretty lights in the sky. It's about the cascading collapse of infrastructure that everything else depends on. No power means no refrigeration, no water pumps, no gas stations, no supply chains. Modern civilization runs on electricity, and electricity runs through transformers. So what's being done? NOAA's Space Weather Prediction Center now monitors the sun around the clock using satellites at the L1 point, a million miles toward the sun. When a coronal mass ejection launches, we typically get 15 to 60 minutes of warning before it arrives. That's enough time to alert power companies, reroute satellite operations, and divert aircraft away from polar routes where communication blackouts are most severe. Some grid operators have begun installing blocking devices that can protect transformers from geomagnetically induced currents, but deployment is slow and uneven. There's no federal mandate. Some states have taken action, others haven't. The Solar Orbiter mission, a joint project between NASA and the European Space Agency, is now observing the sun from angles we've never seen before, including above and below its poles. In early 2026, researchers published findings tracking one of the most extreme active regions in decades, almost continuously for 3 months, using both Solar Orbiter and Earth-based observatories. That region triggered the strongest geomagnetic storm since 2000 Bell. We're learning more than ever about how these eruptions form and evolve, but predicting exactly when one will fire directly at Earth remains difficult. Picture this. You wake up one morning and your phone is dead. Not just out of battery, completely fried. Your car won't start, neither will your neighbors. The traffic lights are dark. The grocery store is closed. And when you try to find out what happened, there's no internet, no radio, no way to know how far the damage extends. That's the scenario engineers quietly worry about, not because it's certain, but because it's possible. The sun doesn't care about our infrastructure, it doesn't negotiate, it simply does what it's done for billions of years. The good news is that most solar flares, even powerful ones, don't hit Earth directly. The sun is big, space is bigger, and the geometry has to line up just right for maximum impact. The bad news is that the more flares we get, the more chances there are for that unlucky alignment. And according to the latest projections, we're entering a period where the odds go up, not down. Remember the pattern, strongest flares come after the peak. We passed the peak, the window opens soon. So here's the question worth thinking about. If scientists are right, and an extreme flare does happen in the next 18 months, what would you do with a 1-hour warning? Would you know where to go? What to grab? Who to call? Most of us don't think about the sun unless it's giving us a sunburn or a pretty sunset. But up there, 93 million miles away, a ball of plasma 1,000,000 times larger than Earth is twisting its magnetic field into knots. Occasionally, it releases, and when it does, the only thing standing between us and a very bad day is a thin magnetic shield and some luck. The sun isn't finished with us yet, whether we're ready or not.